Welcome friends to my YouTube channel Sommo Physics. Yesterday I have discussed about the variation of G with respect uh, with Earth's rotation, and there we see that acceleration due to gravity at the poles is maximum and that at the equator is minimum. And we also discuss few problems related to central force. Okay. Now today we will discuss another application. If an object is dipped vertically through a tunnel bored on the earth, then we see that the motion is simple harmonic. Okay, so let's proceed. Suppose the particle is dipped from this point. Okay, at any instant the particle is dipped from this point. At any instant it reaches to that point. Okay, suppose this is a point. At any instant the particle reaches at that point. Okay, now this point where the particle is now at present condition is located at a distance x from the center of earth. Okay, the point where the particle is now located is at a distance x from the center of earth. That means this distance is x. So we imagine an sphere of radius x. Okay, so imagine a sphere of radius x. Okay, so at first we have to find out the mass of the sphere. Okay, now what will be the mass of the sphere? Mass of the sphere will be, say, m dash, volume into density. Now the volume of a spherical shell of radius x, that is 4/3 pi x cube into mean density of earth. So this is the mass of the sphere. Okay, now we all know what will be the force of attraction between the object and the sphere. Now the object is exactly located at the surface of the sphere, so it will experience a maximum force of attraction due to this sphere. Okay, of radius x. So what would be the force of attraction? Minus g into mass of the spherical shell or inner sphere, 4/3 pi x cube rho, into mass of the object, say m, upon x square. Okay, m is the mass of the object. Okay, so if we simplify it, then what we get? Minus 4/3 pi x rho m g. Now this force acts in the downward direction, because with that force the earth is attracting the body in the downward direction. Okay, now we know that there is an equal and opposite force in the upward direction. Okay, there is an equal and upward force in the upward direction, and what will be the expression of that force? That force, if x be the displacement, then that force will be m into d2x dt2. This must be equal to minus 4/3 pi x rho m g. So m cancels. So what we get? d2x dt2 plus 4/3 pi rho g x. This is equal to 0. Okay, so we can write this expression as d2x dt2 plus omega square x. This is equal to 0. Thus we see that the motion is simple harmonic. Okay, where what we get? Where we get omega, this is nothing but the 4/3 pi rho g whole to the power half. This is the angular frequency of oscillation. So this is basically motion is simple harmonic. Okay, motion is simple harmonic. Okay, so we have seen that the motion of simple harmonic and the angular frequency of oscillation is this. So let us proceed further to find out the time period. Okay, So in order to find out the time period, we must have to know omega. So we find omega. Okay. So we find omega as 4/3 pi rho g to the power half. Okay. Now again another formula, we again know that density of earth can be written in this way, 3g by 4 pi rg. Density of earth, that is can be written in this way. Okay. How? Because by using that formula m, this is equals to 4/3 pi r cube rho. Okay. And also by substituting the value, we can write rho, this is equals to atho. Okay. By using this expression and simplifying, we can write simply rho equals to 3g by 4 pi rg. Or you need not to remember that, you only remember that mean density can be is related to the radius of earth by this relation, rho equals to 3g by 4 pi rg. Now if we substitute this in the value of omega, then we can get 3g by 4 pi rg to the power half, or simply 3 cancels, 4 pi cancels, and g cancels. So what we get? We get g by r to the power half. Okay. Now what will be my time period of oscillation? That is simply 2 pi by omega. So what we get? 2 pi r by g. This is the formula. Again, this formula we arrived, which we arrive in case of a satellite. While doing find out the orbital velocity and time period of revolution of satellite, we find this formula, and there I told that this formula, we require this formula in many cases in classical mechanics. So this is the actual formula. Okay. Now if we substitute it, r, this is equal to 6,400 kilometer into 10 cube meter, and if we substitute g, 9.8 meter per second square, then the value of t will approximately become 84 minutes. Okay. So this is the time period of required by the particle if we dipped it through the tunnel bored on the earth. Okay. So this is the time period of oscillation of the object if we dip an object from earth's surface into a tunnel which is bored through the earth. Okay. So this is clear. I hope you will understand it. Okay. So this is the one problem, and our next we will move into another problem. Okay. Let us try to find out another problem. Okay. Now our next problem, this is, suppose we have to show that a satellite, while revolving around a planet, we all know that a satellite revolves around a planet. Now there is a system where is a satellite revolves around planet. Now we have to show that air friction will increases the velocity of the satellite. This is also a conceptual question. How we can check it? Suppose this is earth of mass m, and this is a satellite of mass m. Okay, the satellite revolves around the earth in an orbit of radius r with orbital velocity v. So what we get? We all know the stability condition, that is gravitational force of attraction. This is equal to necessary centripetal force. Okay. Now what will be gravitational force? That is gm into m by r square. This is simply mv square by r. R cancels. So what we can write? mv square r. This is equal to gmm. Now we can write this mvr into v. This is equals to gmm, and that can be written as L angular momentum. This equals to gmm. So what will be my V? My V will be gmm by L. So give it a name, say equation 1. Now we all know that at first you think about the linear motion. Now we all know that air friction can directly affect the linear momentum in case of a linear motion. So if air friction affects linear momentum in linear motion, then air friction will also impact or reduce the corresponding angular momentum in rotational motion. Okay, we all know that air friction reduces the linear momentum in case of a linear motion. So if that reduces the linear momentum, it will also reduce the angular momentum in corresponding rotational motion. So first remember that air friction reduces L, that is angular momentum in rotational motion. Okay, so if the angular momentum reduces, then what? Velocity V increases. Okay, thus we see, due to the presence of air friction, the velocity of the satellite increases. Okay, so this is another conceptual question. So at first, make Fg equal to Fa and substitute the values, we get the expression of V. Now here you must have to write that due to the presence of air friction, the angular momentum reduces, so the velocity of the satellite increases. Okay, so thus we arrive these two problems. Okay, we arrive these two problems. Okay, now there is an these are the few problems related to central force and gravitation. Now in today's lecture we have discussed about the motion of an object which is dipped through the tunnel on Earth, and we also discuss a problem based on the satellite. Okay, now in our next class I will discuss about gravitational field and potential. Okay, gravitational field and potential. So in today I tell the what is gravitational field and field intensity. Okay, what is gravitational field and field intensity? In my previous lectures I told that. Now today I shall recapitulate that what is gravitational field and what is field intensity. Okay, what is field and field intensity? Now we all know what is gravitational field and field intensity. We all know that the space around a body, suppose there is a body and this is the space around it within which its gravitational force of attraction can be experienced. Okay, then this region is called the gravitational field. Okay, suppose there is an object lie there and this is the region within which its gravitational force of attraction can be experienced, then this region is known as the gravitational field. That is gravitational field, that is the space around a body within which its gravitational force of attraction can be experienced. ঠিক আছে, the space around a body within which its gravitational force of attraction can be felt is called gravitational field. Okay, so this is the definition of gravitational field. And there is another term I should tell, that gravitational field intensity. We all know it. What is field intensity? I also told it that field intensity at a particular point is defined as the force experienced by a unit mass placed at that point. Suppose this is the object and this is the gravitational field region. So suppose if you place a unit mass, suppose at that point, then the force experienced by unit mass is called the gravitational field intensity at that point. Okay, suppose this is the gravitational field and you put a unit mass at that point, then the force experienced by that unit mass is called the gravitational field intensity at that point. অর্থাৎ force experienced by a unit mass at a particular point, in gravitational field, okay, the force experienced by unit mass placed at a particular point is called gravitational field intensity at that point. Okay, so in our next class I will discuss about few examples of gravitational field intensity and potentials, and we would mainly discuss two things, spherical shell and solid sphere. Okay, so that we can do in our next class. So dear guys, if you don't subscribe my channel, then kindly subscribe it and share it to your friends and relatives to get latest updated videos based on higher secondary and graduation physics. Okay, thank you.